Welcome back to Chemical Foundations. We're on part 3, the last video of this unit. Right now we're going to talk about the metric system and conversions, factor label, temperature and pressure units specifically, and density. So let's get started. First of all, the metric system. The metric system is on a base 10 scale with base units of meters and liters and grams. Notice that the liters is a capital L. If you use a lowercase l, that might as well be a 1. So make sure liters are always capital. So let's just talk about what one of these rows mean. Pico is a prefix, so it could be a picometer or picoliter or a picogram. What this means is 1 times 10 to the negative 12 base units, let's say grams, are equal to 1 picogram. Or if you wanted to look at it opposite, 1 times 10 to the positive 12 picograms is equal to 1 gram. And usually that's the way we're going to look at it. We'll make the bigger unit with the 1 and the smaller unit with the number. So we'll make these guys have positive exponents instead of negative exponents. And again, common conversion factors, this is just, keep it handy. You're going to have to refer to these at some point throughout the school year, probably at several points throughout the school year. So for both of these, just keep it handy. Start with factor label. Your book and some other places call it dimensional analysis. We typically call it factor label. It's just a method of converting one measurement into another, from one unit into another. We need conversion factors created from an equivalency, and it's always equal to 1. So the equivalency here we're going to use is 2.54 centimeters is an inch. So if you put 2.54 centimeters over an inch, that's the same as saying 12 divided by 12 is equal to 1, because the top number and the bottom number are equal. Or you could flip it, and it's still equal to 1, because the top number and the bottom number are equal. So we're going to multiply a quantity by conversion factor so that the undesired unit cancels. Let's take 31.8 centimeters. I'm going to multiply it by the conversion factor that has centimeters on the bottom so that they'll cancel. And that's 1 inch divided by 2.54 centimeters. So 31.8 divided by 2.54 is equal to 12.5. And the centimeters cancel, so my unit is inches. Some examples of factor label. This first one, I want you to try yourself first before you watch me give you the answer. Pause the video now. Hopefully you pause the video. Let's look at the answer. What is the weight of a 2.3 pound pineapple in milligrams? So we're going to start with the thing we know, 2.3 pounds, and we're going to milligrams. I see pounds in this conversion chart here with kilograms, and I also see pounds with grams. Either one of those gets me to metric, so either one of those will get me to milligrams. I'm going to try this top one because grams to milligrams seems simpler to me. So pounds is going to go on the bottom so that it'll cancel. Grams is going to go on the top. The equivalency, 454, goes with grams, 1 goes with pounds. Problem is that's not milligrams. I need one more step. The unit I'm trying to cancel goes on the bottom. The unit I'm looking for goes on the top. If you think about the previous slide with the conversions on it, gram is 1, milligrams is 1,000, or 1 times 10 to the third. So that's 2.3 times 454 times 1,000 will give you 1044200. And then the units, pounds cancels, grams cancels, milligrams. Now, if you remember, we previously were looking at significant figures. 2.3 has 2 significant figures, and these numbers, the conversions, are exact numbers or counting numbers or definition numbers. Do not look at those for significant figures. You're only looking at the number they give you in the problem, 2. So that's 100000. Really, I only want the first 2 to be significant, so I cannot write it like this. I'm going to have to write it as 1.0 times 10 to the 6. And milligrams. Let's try another. So in this case, what's the volume of a the volume of a solid is measured by water displacement. When the solid is placed in a graduated cylinder containing 20 milliliters of water, the water level rises to 23.2 milliliters. What's the volume of the solid in cubic inches? So first of all, what's the volume of the solid in milliliters? 23.2 milliliters minus 20, which is just the water, gives me 3.2. When you're looking at significant figures for subtracting, you're looking at places past the decimal. This number has 1 place past the decimal just like the other 2. So this is a correct number of significant figures, 2 total. So I've got 3.2 milliliters. I'm going to try to change that to cubic inches. So I've got milliliters to cubic centimeters, and I have centimeters to inches, so those are my conversion factors. Start with milliliters to cubic centimeters. They are the exact same thing. And now I'm going to go centimeters to inches, 2.54 centimeters, 1 inch. The problem is this is a centimeter cubed and this is a centimeter not cubed. So since I need it to be cubed, I'm going to cube everything in the problem. Cube it all. So really 2.54 centimeters cubed should be 16.38 centimeters cubed. And 1 cubed inches cubed is the same as 1 inch cubed. So now we're going to take 3.2 divided by that 16.38, and I get 0.19536 inches cubed. Since we need two significant figures from my original 3.2 milliliters is two significant figures, I'm going to round that to 0.20 inches cubed. That is because the 5 will round up the 9, which will then round up the 1. Make sure you include that last 0 here to give it two full significant figures. Let's try another. A Japanese car is advertised as having a fuel economy of 15 kilometers per liter. That's the way they would measure it in Europe. We want to know what this rating is in miles per gallon. So the kilometers is going to have to convert to miles, and the liters is going to have to convert to gallons. So let's start by seeing what conversions we have. Well, liters and gallons, that's going to be right here. As far as kilometers and miles, I have feet and miles. I have inches and feet. I have inches and centimeters. And centimeters is metric, so that can go to kilometers, so that's the way I'm going to do it. First of all, 15 kilometers per liter is the same thing as saying 15 kilometers per 1 liter. Liters on the bottom. So when I want to convert liters, I'm going to cancel it by putting it on the top. 3.79 liters is 1 gallon. This will cancel the liters on the bottom with the top and leave me a unit for gallons. Now let's convert the kilometers. Since I'm trying to go from kilometers to centimeters, it might be easier to go from kilometers to meters first, and then from meters to centimeters. That's up to you personally. You might have done it differently. So now I'm going to go from centimeters to inches. 2.54 centimeters, 1 inch. And inches to feet. 12 inches, 1 foot. And finally feet to mile. 5,280 feet, 1 mile. Let's look at the canceling units. Kilometers cancels, meters cancel, centimeters cancels, inches cancel, feet cancel. I'm left with miles. So my final answer, 15 times 3.79 times 1,000 times 100 divided by 2.54 divided by 12 divided by 5,280 gives me 35.325 miles over gallons. Since my original number has two significant figures, I only want two significant figures, so let's convert that to 35 mpg. That's a pretty good fuel economy. Okay, next thing we have to talk about is density. Density is an object's mass compared to or divided by its volume. Density is equal to mass over volume. So here's my first density problem. A student is trying to determine the density of an unknown liquid. The student places a graduated cylinder on a balance and determines its weight is 12.32 grams. So the mass of the cylinder is 12.32 grams. The student then places 20.2 milliliters of liquid. Volume of liquid is 20.2 milliliters in the cylinder and places it on the balance again. This time the balance reads 29.73 grams. Mass cylinder plus liquid is 29.73 grams. So what we're going to have to do is subtract the two masses from each other to figure out the mass of just the liquid. 29.73 minus 12.32 is equal to 17.41 grams. 2 places past the decimal gives me my correct number of significant figures. Then the density is equal to the 17.41 grams divided by 20.2 milliliters gives me 0.86188, which is close to 0.862. Notice that on my list I don't have anything that's 0.862, but I do have one that's really close to that. So my guess is that this is going to be toluene. Another density problem using the same chart as the problem above. A student would like to collect 350 grams, that's going to be a mass, of diethyl ether. What size beaker should be used? Okay, well I have the density of diethyl ether. So with this formula, density is mass over volume. I have mass and density, which means I'm going to be looking for volume. It's going to be mass divided by density. So I have 350 grams divided by diethyl ether is 0.714 grams per centimeter cubed. And that gives me 490.19 centimeters cubed. So approximately 490. The question is not what is the volume of the liquid, but it's what size beaker should be used. So I would think any beaker that's at least has a capacity of 500 milliliters would probably fit my liquid. Anything that's at least 500, so 500 or 750 or 1,000, anything bigger than 500 milliliters will fit that liquid. So our last density problem, what's the mass of 1.25 quarts of isopropyl alcohol? What is the mass? Means mass is what I'm looking for. 1.25 quarts, that's a volume, and I have a density. So if my formula density is equal to mass divided by volume, and I'm looking for mass, so mass is equal to density times volume. So let's just go ahead and plug in what we have. Density for isopropyl alcohol is 0.785 grams per centimeter cubed, and the volume is 1.25 quarts. So it looks like all I have to do is multiply those. Problem is, when I'm looking at my units, these are not the same. Centimeters cubed and quarts are not the same thing, so they're not going to cancel. So I need a way to convert either quarts to centimeters cubed or centimeters cubed to quarts. So let's look back at that conversion chart you got earlier. So again, same problem. What is the mass? Is equal to density times volume. But this time I'm going to change the 1.25 quarts to centimeters cubed. That way the units will match. So factor label this 1.25 quarts. I have quarts in pints and I have quarts in gallons. I have gallons and liters, liters and milliliters to centimeters cubed. So I think that's the way I'm going to go. 4 quarts, 1 gallon, and then 1 gallon, 3.79 liters. And then 1 liter is 1,000 milliliters. This is not on your chart, but this is how I'm going to convert metric. And remember, a milliliter and a centimeter cubed are the exact same thing. So that's a really simple one. So to get my quarts to centimeters cubed, that's 1.25 divided by 4 times 3.79 times 1,000, and just that, and I end up with 1184.375 centimeters cubed. Now, only 3 of those are going to be significant, but I want to keep the entire number when I'm typing in my calculator. I only want to round at the end. So mass is density, and for isopropyl alcohol, again, it's 0.785 grams per centimeter cubed times 1184.375 centimeters cubed. It might be easier just to store that number in your calculator and just hit multiply by 0.785, and you end up with 929.734 grams. My smallest is 3 significant figures from both the density and the volume. So 929, the 734 cuts off, but the 7 rounds up, which gives me a total volume of 930 dot grams. That dot is important because I do want all 3 of those numbers to be significant. So there we go, 930 grams. I hope you learned something about factor label and density and measurement. See you next time.